In this video, we're going to be working with changing bases and looking at different types of operations that we have. We've got 3 examples up at the board here right now. First, we've got 8 to the x times 2 to the 2x. Then we have 50 to the x divided by 5 to the 2x, and 16 to the x divided by 8 to the opposite of x. What you may have noticed already is that we don't have the same base in any of our examples, and we also don't have the same exponent. Okay, so our powers are completely different. So right now, what we have is a one-step process to get into being able to use our properties of powers. Okay, let's take a first look right here. So here we have 8 to the x times 2 to the 2x. Okay, well, is there any other way that we can express 8? Because there's no other way to express 2, because 2 is a prime number. Okay, we should look for another way to express 8. Now, 8 is 4 times 2, or 2 cubed. Now, if we have 2 cubed, if we replace 8 with 2 cubed, we get 2 cubed to the x power, or to the x exponent. So this, as an entire power, would become, here's a power of powers, so this becomes 2 to the 3x times 2 to the 2x exponent. And now we have similar bases. We've got the same base, and we've got a product of 2 powers. So 3x plus 2x gives me 2 to the 5x. Okay? So we're looking to see a similar base in here. Let's move on to our second example. We have 50 to the x divided by 5 to the 2x. Well, let's look at these two bases that we have. The base of b is a composite number. It's made up of 25 times 2. And let's see what we can do there. 5 is our denominator. Okay, so let's look at times 5 to the x. Okay, this is what's known as its prime factorization. But when we take and divide this by 5 to the 2x, things are starting to look more and more promising. Here we've got 5 squared, here we've got 5 to the 2x. Well, we've got one more piece here. We have a power of a product. Okay, so we have this x. So what we find x times 5 squared times x, all divided by 5 to the 2x. As you can see here, we've got 5 to the 2x in the numerator, and in of 50 to the x divided by 5 to the 2x is simply 2 to the x power. Let's move on and try this last piece here. Now, we've got to the opposite of x. So here we have, and is there any way that we could express 16 as a power of 8? Common power? Yes, they do. And that common power is 2. All raised to the x power. And 8, as we saw over in the beginning here, is 2 cubed. So this is 2 cubed to the opposite of x. Now what we have is 2 situations where we have a power of a power. To the power of 3 times a negative x, or a negative 3 times x. And now we have the same base, but we have a quotient of 2 powers. So with the same base, all we need to do is take and subtract our denominator exponent from the numerator exponent, which becomes same base, so 2 to the 4x minus a negative 3x. Well, subtracting a negative produces an addition, and 4x plus 3x becomes 2 to the 7x power. Okay, so that's basically how we work with changing bases, and it's applicable in Algebra 2 as well as pre-calculus all the way up through calculus. Okay, so changing bases.